Good evening. Am I audible? I guess. So today I'm going to talk about causal inference and a bit of distance matrix learning. And this is my work with Cynthia and Alex. So first I'll give a big picture idea of what causal inference is and then go forward with it. So one fine day, Calvin was like, oh, should I date Susie? And Hobbes was like, kid, no. Don't you know, like, dating causes depression in teenagers? Look at this research paper. Dating frequency increases, the chances of depression or sadness increases. Calvin was smart. He was like, no, 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 nobody. The actual thing you need to compare is what is my potential outcome if I was dating, and my outcome being my mental state. What is my mental state if I was dating Susie versus what is my potential outcome when I was single? Awesome. But there is a missing data. I can only observe one of the states. I can observe Kelvin when he's dating or when he's not dating. The other state is called the counterfactual, and I somehow need to estimate it. How do I do that? Typically in literature, there are two methods which people use to do that. The first one being modeling. So in modeling, you can model this science by linear equation and then estimate the parameters, or by some other modeling method, your favorite one, neural network or random forest. Matching, on the other hand, tries to find someone who is very similar to Kelvin and then try, but in the opposite treatment assignment, being single, and then try to see what is the mental state of that person or that group and use that as the estimate of counterfactual. Now, I loosely use the term similar over here, and similar should be under some distance matrix or some similarity matrix, right? What do people use? People in literature typically have been using ad hoc distance matrix, ranging from Euclidean or Mahalanobis distance matrix to something which is defined by domain experts saying that these are the features which are important and you should match on that. But in a high dimensional complex setting, there is no reason for us to believe that people can design true distance matrix. What do? You are in a soup now. Too long, didn't read of our proposal is first use your data, separate your data into training set and learn a distance matrix. Then use that learned distance matrix to do matching and estimate gates. And I will go in the details of my method on the poster, but this was TLDR version of it. Let me quickly jump to the results section of it, which is more interesting. So the graph on the right-hand side that you can see is different methods. So three method on the extreme right, being BART, causal forest, and difference of random forest, are non-matching methods. They are non-interpretable and are said to be state-of-the-art methods. Our method, which is MALTS, is the first one in the blue. So our method is performing almost on par with most of the non-matching black box methods, while our method being matching is interpretable. You can take each person, find who that person is being matched to, analyze that match group, and you know what exactly is happening under the hood. Gen match and nearest neighbors matching are two classical matching methods, and they have been shown to perform poor in the setup that is over here. Quickly jumping to the real data experiment because it's always important to test it on the real data. Here we know the ground truth because this was a randomized control trial, and this program being what is the effect of temporary employment on income levels. This data is infamous for showing that no method, let it be matching or modeling, allows you to get near to correct estimation of treatment effect. There are two reasons for that. The modeling methods tend to overfit the data. The matching methods tend to match on things which you should not be matching, the irrelevant covariates. What our method ended up doing was finding what is actually important and matched on that while dropped everything else. So that's cool. You can really show this thing to policymakers and make sense out of it. What are the future directions? So not saying that this is the whole and soul of everything. We need to do a bunch of things, like if there is contingent, if you are in a flu setting, this method needs some extensions. If you're in a time series setting, it needs some extensions. And I'd like to chat with you about that at my poster. Thank you.